Good morning. Okay, let's see. Today is the 6th of November, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day, and sometimes I stream it here on Twitch. I am working on Basecode, the Bootstrap compiler, trying to finish up the few remaining elements in the Basecode alpha language, at least from the Bootstrap perspective, the parsing stuff for that, and then we can move on to closing off the remaining code generation and translation issues. Hey, Can. So yesterday, I didn't have a whole lot of time, and I don't have tons of time today. That's why I'm starting a little earlier. But I was working on the with construct. Yeah, I just started about 5 minutes ago. And I think I had thought of a couple of approaches on how to do this, and then the more I thought about it, the more I realized, because I was thinking, I could create unary operators that could get translated, or partial binary operators that could get filled in. And then I thought, really, probably the best thing would be to have a distinct node type for this, and then just let the AST evaluator convert it into what it should be. So what I've done is add a with member access and a with member access type to the AST, and this gets triggered on the leading period. So that's what this token is. So I think this should be pretty good. This is sometimes good. Oops. So what we're going to validate here is that the parser is going to land on these dot prefixed variable or reference identifier references, and we're going to parse the identifier properly and create our node and return it. Then with that in place, we can go to the AST evaluator for the width expression and try to do the necessary substitutions. Okay, so we landed in the parser. Token should be a period, which it is. We're going to look for an identifier. We're going to create a symbol from it. So now node left-hand side should be dot items. So we have a member with access, and the left-hand side is a symbol with one child that has one part, and that is items. Okay. And really briefly, if we look at the location, the start is line 16, column 13. The end is line 16, column 19. So yeah, that looks about right. So go. Oh, we're in the for-in statement. In the right hand side is null because, yeah, we don't have a translator for it, right? So okay, so the parser is doing its part now. These are being turned into with member access ASP nodes. So if we look at, helps if I can type. We're going to want to focus on this part over here. So this is the statement at the top level of the file that is the width. On the left of the width, we have the symbol or the identifier, right, that we're trying to resolve as the parent part of the width expression. Then inside of the width, the right-hand side is the basic block that represents statements that are within that scope. So then we have a for loop, and the induction variable for that is I, and then the right-hand side, we're doing a with member access for something called items. And then inside of that for loop, we have a block that has a with expression that is doing a with member access for I. Right? So this is going to be scoped to this, and this is scoped to this. And then we have a basic block within that with expression that is a procedure call, which is calling a namespaced symbol support print. And then the argument list is, so this is good because yesterday I made this conjecture and this proves it. So the first argument is a regular member access binary operator p.name, which is exactly what I would expect. And that is fine because that is going to get resolved just like any other member access. And then we have the string literal, and then we have the with member access which is dot name. Okay, so the AST looks bueno. Sort of. There is no garbage collection. This is manually managed memory. But long story short, if you wanted to build your own garbage collector, you could. All right, so here is my next challenge. I'm going to rerun this. Okay, so we're in the AST evaluator. It's found with expression in the AST, and we're going to try to convert it into our compiler object model. And it's not doing a whole lot that's super complex. Excuse me here. That's not right. Okay. All right, so here is our challenge. Fight. We're width has a block, which is just normal block, right? So we want to use all of the recursive evaluation mechanisms that we already have in the compiler to deal with anything that's in the block, including nested with. So, but here's the issue. That means we need to be able to translate these to model elements, compiler model elements on the fly. So we have AST nodes now, but those AST nodes they're missing something, right? And what they're missing is a reference back to the width they belong to. If we had that, if every one of these AST nodes here with member access nodes, like say on the right-hand side, or I could shuffle it, on the left-hand side, they had a pointer back to the AST node that is the width statement that they belong to. Then in the AST evaluator, we'd be able to implement a standard recursive evaluator for these, because they would have everything that they need to translate themselves into a proper binary expression, because that's essentially what that evaluator is going to do, right? What this is going to become is like, if we're gonna ignore scoping for a second, right? That's what it becomes. So it's just syntactic sugar, right? So that you don't have to repeat yourself with common prefixes. All right, so that explains what we have to do. So we're going to add a new evaluator with member access. Okay, so I wired that up into the evaluator map now, so that type is now handled by the AST evaluator, but we're missing information to do this properly, so gotta fix that. All right, so the question is, how. So what we're going to do we're going to create a with node from the builder. Then we're going to tell the AST builder to push the width onto the width stack. So now for the scope of parsing the expression, so we have width, some expression, then a block, right? Or a single statement, it doesn't matter. So for the duration of this process, that is going to be the top width on the stack. So that means then when we create member accesses, if we say what's the current width, then we can plunk that onto, and I just realized I don't want raw here. Yeah, so then we can just pop. Right. Because we've then recursed, and if we have nested with, every time we come in here, that current one is pushed onto the stack. Now if we go to with member access, let's shuffle this because we actually haven't used anything yet. And we'll do parser, AST builder, current width. There you go. So now our with member access, the left-hand side is a pointer, shared pointer to the same AST node that is the width, and the right-hand side is the identifier expression after the dot. And we discard the dot. It's there for syntactical purposes, but after it's parsed, we don't have it anymore. So then in the AST, we need to okay. So there's our implementation for the width stack. take a look. Pointers are great. Excuse me. All right, while that's compiling, come on, you can do it. I know you can do it. So there is another problem here where I assumed this needed to be an identifier reference, but that may not be true. Because it could be like I'm doing in this example where I have with something, with dot something. Well, then at that point, it's not an identifier reference, it's a binary operator. It will be a binary operator. So we need to revisit this, right? This just needs to be an element, right? So I think we got to go all the way back here to with. We can't assume that this is just a simple identifier reference always, because that's not going to work. So, yeah, this needs to become an element pointer. It's just, so we have with expression body, and that expression could be any valid resolvable expression. Then we don't have a type problem here. We don't have to cast it anymore. We would still call resolve symbol or evaluate, but we don't need to cast it. And the block stays the same. Nothing changes there. I've been in the Cincinnati, so I guess you would say what? The southwestish corner of Ohio and the northern part of Kentucky now for about a month, and it is humid. I hate humidity. I can't stand it. Just sitting here, right? Like I feel it. Ugh. And I know it's raining. It's been raining pretty much the whole time I've been here. I bet the humidity level is like 90%. Yeah, getting a lot of. We're not quite. Holy cow! Yeah, that's like right. Boom. Yeah, that's like right on top of me there. That's great. Yeah, so it's 60 degrees, but we have massively nasty weather on top of us. And yeah, humidity is 90%. That's great. That's great. I can feel it. It's disgusting. Okay, I'll stop whining about humidity. Okay, here we go. So, Parser, ASD builder, with stack. Oh, I forgot this debugger does not. All right, so let's see what we got. Yeah. So there's our width expression. And the expression on this should be P. P. Yes, good. That is the correct answer. And the second time through, this should be the one that has, one that has nothing. Well, that's not good. Oh, wait. Yes. Okay, so we should not push the new width until we're going to parse. Right, because this needs to be in the context of the previous, the expression, right? So this part is in the context of whatever was active here. Yes? Oh, but yeah, see, this is not even, like I did that wrong. Like I didn't need a dot there. But if I had one here, I don't want to push the scope of this onto the width stack until after I've evaluated this in the context of that parent, right? So that's a little goofy. I shouldn't have had a dot there. The dots down here are okay. Okay. So before we recompile, let's fix this. Okay. So that tidies up that part. Now this part, okay. So now building the width element is properly typed. We don't need to do that cast anymore. So that's good. So we're just going to resolve or evaluate whatever's there. We're going to evaluate the block. That's going to recurse. So So then for with member access, we are going to builder make binary operator and scope operator type T is member access. And the left-hand side is going to be context node left-hand side, left-hand side. We need to evaluate that. The with prefix, the left-hand side is the expression, whatever that is. The right-hand side is the block. But we're not, that's the with, right? So we need the expression part. That's going to be the left-hand side of our binary operator. And then context. Then this is the right-hand side of the node. Like that. Right, so because what we're doing is, again, we're taking the parent part, the with. So the with is defining some path to something. That's the left-hand side of the member access. Then the with member access node itself in the AST represents the right-hand side of that, and we've associated those to the correct with in scope. Right. So we already have a mechanism, and this already generates code that's correct, that does the member access from left to right. So we're just turning those parts, we're kind of turning it inside out, into binary operators that do the right thing. All right, so let's go back here. And member access, let's take a look here. Let's put a breakpoint after those. Make sure those are looking correct now. It should, because I fixed my example, but also moving where the new with gets pushed onto the stack is also important. Very cool. So sort of a dot this concept specific to this construct. How are new references accessed to getter? Oh, so there's no There's no OO here, so there are no getters or setters. This is all, so Basecode is, oops, I goofed. Forgot to refactor something. Okay, so Basecode is, I gotta really refine my elevator pitch on this. Think of it as 3 layers, okay? The very first layer is a statically typed, native compiled meta programming language. The language itself is more or less like C. It has, I think, some improved, it's a better C, right? It has better scoping rules, it has namespaces, it has a module system. It isn't, there's no header files, it's not definition order specific, so you can define things in any order you want, and the compiler will resolve things at the end for you. There is I have an intelligent string type. It's tracks a length and a capacity, and it also behind the scenes takes care of tracking a null byte, so it's compatible with C and other legacy environments, but internally it's not brain dead. I have an array type that can be dynamically sized. The for loop is designed to automatically iterate seamlessly over an array. I have a map type, like a hash table, hash map that's built in. Again, not brain dead. But that's basically it, right? You have arrays, you have primitive types, you have strings, you have maps. That's what the language supports at that low level. It supports inline assembly for the bytecode. So the Basecode compiler at this lowest layer, it takes the Basecode source code. So this is what Basecode looks like. It takes this and it turns it into an internal bytecode that it understands. It does that because it's a meta compiler, which means that you can write code that then runs itself, which then makes more code, which repeats that process until it reaches an endpoint, at which point then that bytecode, it get translated to a native target, right? So it could get translated to x86 64 or ARM or Arduino, whatever, doesn't matter. What am I saying? Oh my gosh, Atmel. Thank you, Jeff. Jesus, memory. WebAssembly, right? Whatever. So the ultimate purpose of this lowest level is to generate a library or an executable for a target runtime environment. The bytecode is intermediary and it's only intended to be used during compilation. It's not meant to be used after that. That's the lowest level. From that low level, there's a layer on top of that that is the meta programming layer, and that's going to allow you to generate code to solve problems from that lowest layer. And then on top of that is going to be a final layer that will allow you to define new languages very trivially, right? New transformation constructs where you can define a grammar and you can define how that grammar interfaces with an input stream. And then from there, you can say, okay, when I get an AST from that, generate this lowest level Basecode source. So it's taking this foundational thing, which is manual memory management, powerful, but convenient. Again, it's like a 2018 version of C. And I say that, but in my mind, it's like somewhere between assembly language and C, right? So Basecode, the lowest level of Basecode is intentionally simplistic. It doesn't have anything fancy. There's no OO. There's no garbage collection. There's no anything, right? It's very basic intentionally because you need to be able, I want to be able to target small embedded devices or, you know, build web apps if that's what you want to do, but you need to have something that can be close to the machine to accomplish that goal. Then you can build whatever other kind of abstractions on top of that you want. So if you want garbage collection, easy, build it. Build a generator that does that for you. Build a meta program that does that for you. If you want OO stuff that is vtable based, or heck, if you want to build like something like Smalltalk or Objective-C, where you have something like obj message send, right, where it's all dynamic, you can build it, right? Easy. And you eventually here, like a year down the road, you'll be able to add syntax to do that kind of dynamic message sending if you want to. And it would just be built in. So that's the elevator pitch. Okay, yes, good. So those are both set. What didn't we like here? Oh, crap. Recursion. Didn't think of that. You know, do I need the whole width node? I don't. I only need the left-hand side of it, right? Which is the expression. So then that means here, yeah, so I need to refine my elevator pitch. Eventually I'm going to write this stuff down. So kind of trying to timeline what I'm doing right now to the elevator pitch goes like this. I am working on what's known as a bootstrap. Okay, so when you build, typically, not always, but typically, when you build a new programming language, you need to bootstrap it because you ideally want to self-host your language. Or I've always kind of taken that approach. But how do you do that? How do you, oh, okay, yeah. Let's just go back to something simple here. That's kind of what I originally started with for testing. I mean, actually, what I originally started with was like this. That's what I started with. So you have to typically write the first version of your compiler in a different language. So I chose C++ because that's what I know, what I like. Okay, so now we're back to, why is it not resolved? Because that should be getting converted. Oh, wait. length, capacity. All right. So what do we got? Yeah, so what was I saying? So I'm building a version of the compiler in C++ for, again, this very base layer of the language to get it to a sufficient point where I can use that to then, within the language I'm designing, rewrite the compiler, right? So we start with C++. I then rewrite the compiler for that base layer in the language I'm designing. It's now self-hosted. I expect the language to change some between where we're at now and the end of the self-hosting process. But that's generally where I'm at. And then some of those higher level features I talked about, that's stuff that's going to come after we get past self-hosting. So we made an identifier reference for temp, okay? That looks okay. And then made an identifier reference for length. Oh, right, but no, I know what I'm doing wrong. I know what I'm doing wrong. Where's binary operator? Yeah, so I basically need to do we need the scope of that's the trick. That's the trick. But then I even go one step further. I'm gonna need to refactor that code. Because what's happening is, in the binary operator evaluator, right, I'm handling all the, you have something, dot something, I'm taking that left-hand side, and if it's composite type, or it's pointer that points to the composite type, I'm dereferencing pointers, and I'm also getting the scope for the composite type. And then when we do that resolve symbol or evaluate, we're using that type scope if it's different. And that's why it's failing. That's why it's saying it can't find them, because it can't. Slightly different approach here. To reuse the existing binary operator conversion that I have, I am going to cheat. That's the cheating. It's reusing. Because again, like that code, there's a lot going on in there, and I mean, I could try to pull it apart, but the overhead of creating another AST node that represents the new binary operator temporarily and pushing that through, yeah, that works, right? So. What else is I forget? Comments, attributes, scope, no, okay. Yeah. Let's see if that works. Shall we? Yeah. And then the good news is any change we would make to the binary operator expression evaluator, or evaluator in the AST evaluator, the compiler, the with member, yeah, boom, there you go, it worked. There you go. Look at that. So, now we didn't get any print output though. Oh, we didn't because, yes. Did not because with this guy is really nothing directly special here. we need to pass it through. Because with has an expression, which is going to resolve to our left-hand side of our expression or member access. It has a block, a body, and that body we just need to pass the code emit onto that, so it recurses down that chain. There we go. Boom. 1132. It works. Yay! All right. So let's go back to our test file. And yeah. Sweet. All righty. Now here's the challenge. This is about as much real testing we can do with it right now, because even though the compiler will generate the structs, like I can create structs that are complex, instantiating them is not, where we're not quite finished with that on the code generation side. So string is like one of these special cases that I already handled up front, and strings are kind of being initialized properly, so we can do that here. But the basics are working, right? With is doing what it's supposed to do. So let's, actually, before I do that, I just want to eyeball the generated code real quick, because let's just make sure it's not stupid. Right, so here's our temp. We're reserving 16 bytes for the string. The literal hello world is encoded in memory. And so then at the very beginning, we go through the initialization code, right, for types. So string, or temp is a string, right? So we get the address of temp. We store the length of the string into the field, the length field. We store the capacity into the capacity field. We allocate memory for the actual string on the heap. We copy the literal from the program image memory to the structure, allocated memory for the structure. We move that pointer into that field. Then we do our accessing stuff for the length, and we print it, and capacity. Then we free up memory. Yeah. So that all looks right. So nothing there is broken. That's good. All right, so now let's review what I did. So the with element in the compiler itself, when I first wrote this, I assumed that we were always going to have an identifier reference. So we're going to have an identifier reference pointer and a block pointer. But really, the expression there can be quite complex. So we needed to bring that up to just an element pointer, and I changed it to expression because, or the name of it to expert, because that's kind of what I do everywhere else where that's the case. Change the field, change the constructor, change the accessor. The on-emit for with just defers to the body, right? There's like no special code the with itself has to emit here. It's just whatever body is associated to it, that's the code it emits. Our test case, I simplified it because, again, we're going to come back to this. Eventually, we can do what's on the left, right? Hopefully fairly soon. But right now, again, strings are one of the few complex types that are being initialized properly right now. So, but this works. This does what it's supposed to do, right? You can do .length, .capacity, and it figures out that it's temp.length, temp.capacity, and it gets the right values, and all that's wonderful. On the AST side, I added a new AST node type with member access. So I decided that dot identifier, instead of trying to do it at the parsing level, which didn't really make sense, I would just create a new AST node type that represented that unique occurrence in the source, added the name mapping, and then in the AST builder, had to enhance the AST builder a little bit. So the AST builder now has two stacks, one for scopes and blocks and one's for with statements, with expressions. So every time we come into a with, when we're gonna manage, we're gonna parse that block, right? So we do with, the expression, then the block. We push that new with onto the with stack so that everything inside of that block, that's the scope, or that's the with statement that's associated to that block. Added a creator for the with member access node, then added the new stack there. Added code to clear out the stack. I've never entirely understood why they didn't just put a clear on the stack, but they didn't. So you actually have to loop over it and pop stuff off until it's empty. Silly, silly. With the with stack, you know, popping whatever is on the top, getting the current, and then pushing a new node on there, pretty straightforward. And then creating a member access node is pretty easy, right? Pretty standard stuff. Hey, Synox. Okay, so then in element builder for making a with, again, I had to change the types here. So it's an element pointer for our expression, and we just pass that through. The code DOM formatter, the accessor changed. It was renamed, so instead of ref, it's now expr. So just change that. Then finally, in the, let's look at the parser. So the with member access prefix parser, so we started this yesterday, but I finished it this morning. So we create the with member access node, we get the correct location start from our tokens. We're expecting an identifier token. So it's got to be dot some identifier. Then what we do, so the left-hand side of the member access node in the AST is going to point at the expression of the current width on the width stack. So in the other part of this, where we create the width node, we push it on the stack. And then the right-hand side, we just create the symbol like we normally would. And yeah, so then the with prefix parser, right? We we parse the expression. So the expression should always be evaluated in context to the current scope, right? The current width scope. Not the previous. And then when that's done, we're going to push this new width onto the width stack. We're going to evaluate the right-hand side of the width node. So this gets evaluated with this on the stack, which is what we want. When we're done, we take it off, right? So if you had width and some stuff, width and some stuff, width and some stuff, as you go, you know, deeper, 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 each new width construct gets pushed onto the width stack, and you have this whole chain all the way back up. Yeah. And that did just make me think that that probably has to be recursive. So I'm gonna, so if you did width, within width, within width, because that left-hand side, right? Yeah, I might have to revisit that, but I think most of the structure's in place. Oops, wrong key. And then in the AST evaluator, added with member access for a new type, and added that to the evaluation map, right? So for this type, we call this evaluator function. And if we go to that evaluator function, this is very simple now, because on this with member access node, left-hand side is the expression node of the with. The right-hand side is the symbol we parse from the dot whatever. We just make a new binary operator with the period, right, so with the member access. And then we just use the existing binary operator evaluator to turn that into the correct element, right? So this is really, by definition, you know, a good example of syntactic sugar, right? And that, I think, is that. So if I understand EDISDO correctly here, I think what they're saying is, let's say that in my Bootstrap compiler, I used a third-party library. Like, let's say I used Yak or Lex or something, right? And then when I would go to rewrite to be self-hosted in Basecode, Yak and Lex don't support Basecode. So I'm kind of immediately at a deficit when I start rewriting it, because I use this tooling that only exists in C and C++. Or, you know, like another good example, this is actually a real example. I'm probably going to use, for the Bootstrap compiler, a semjit and like elf.io. Those are real libraries in the C and C++ space. But when I bootstrap, or when I rewrite this to be self-hosted, I probably will not reuse a semjit or elf.io. I probably will write, I'll probably rewrite those. So that's, you know, oh, I gotcha. Yeah, I'm not sure I understand those either. I picked up on the dependency part, but okay. So let me where'd it go? Huh. is so weird. Like it just disappeared. Okay. Never had that happen. I had a browser window that I was trying to drag over, but like, yeah, it just, I don't know. It just disappeared. So I will open another. Okay, so width, I am going to say width is done at this level, right? Again, I'm trying to finish up things that are missing in the parser specifically. There's going to be probably tons of stuff I'm going to have to come back and deal with on the code generation side and all that, but which is all this stuff. Okay, so that leaves yeah, I can run code. It runs inside the virtual machine, inside the compiler. It's simple stuff. Like, I think the most complex example I've got is while loop. Yeah, because this does fizzbuzz and then does some other really goofy looping stuff. So let's run that, because I haven't run that one in a while, so I don't even know if it will. Should still run. Yeah, it runs. So we got fizzbuzz, we got this weird loopy thing I did. So yeah, it works. So yeah, I mean, this one's pretty good because it's got variables and I'm changing them, it's looping, I'm printing, I've got conditionals, I've got breaks and continues, I've got continues with labels. Yeah, there's quite a bit in here in this one example. So, all right, so I think the next thing is for loops. So let's talk about for loops, because I got about 20-ish minutes here. Sorry for asking a dumb question, but if you intend this to be self-hosted in the future, why write it in C++ in the first place rather than a simpler language? Well, simple is in the eye of the beholder, right? I don't consider C++ to be complex. So that's one thing, and I'm not trying to be snarky, but like C++ doesn't present a obstacle for me compared to anything else, really. And on a different angle of that question, we kind of talked about this a couple minutes ago, where Eatus was mentioning, technical debt and dependencies. If I use, like, say, Python, right, or which is what I am assuming you're referring to, why not use Python? Why not use JavaScript? Why not use Ruby? Why not use Java? Why not use C#? Well, because, see, with C++, I have a pretty good understanding of when I use something, what that is. And in most cases, I even have access to the source code for pretty much everything. So if I say use Python, I could very quickly bury myself in a bunch of high-level constructs that I can't easily reproduce, right? So the way I'm thinking about it is it's paradigm matching, right? I'm not building a language like Python. I'm not building a language like Java or C# or any of those. I'm building a language like C, with some newer concepts, in the syntax and some things that if I were to take C and try to tidy up the language a little bit, this is what I would come up with, right? And so by using C++, I'm a bit outside the box of what I'm building, but not by too much. And if I had used Python or Ruby or whatever, like I say, I think it would be, the mapping of concepts would be very difficult when I go to self-host, right? Because, they're not the same paradigm. So that's ultimately, those are my reasons for why I chose C++ versus some other high-level language. So. Yes, C++ has twisted me. So for arrays, so this actually does model translate right now. I don't want to say it compiles because it actually doesn't generate any code yet. And there's a bunch of issues here. Yeah, this is what it generates. Implement for. So this is the general construct I had in mind for loops. I was not thinking that I would support range-based syntax, because to me, you can kind of get to the range-based syntax with a built-in, like I can have an intrinsic called range, right? That's 0 to 10, and if I want to go in reverse, right? If I wanted to go 10 to 0 or 10 to 1 or whatever, right? I could just swap that, and then the range intrinsic, now, and then if we did that, if I did like a range intrinsic, this could actually just be a code generation for syntactic sugar, meaning that because this is a range expression, I would know, I don't even have to generate the array or anything. I can just generate, like this doesn't actually generate any code. It just ends up being parameters for, the for loop, right? So I think doing it something like that. So obviously if you want to do like a numeric range, you do it this way. What about stepping, right? So, well, again, like to me, if you wanted to do stepping, that could just be another parameter in the range, right? Range from 0 to 10, stepping by 2, right, or whatever. And obviously, if you did it the other way, whatever, it would handle it for you. So I think that handles range-based for loops. And of course, similar to other constructs, I'd let you put a type here so that you know, don't have to specify it on the left if you don't want to. So if for whatever reason you did want to range over bytes or signed bytes or 16-bit integers or whatever, you do that very trivially. So we need to, you know, add the range intrinsic. So that's one thing. And params are start, stop, step. And go from low to high or high to low. All right. And so that's one example. The other is what I had in here already. So obviously, if you have an array, I'm going to automatically support, you know, iterating over arrays in the language and maps. Now, so number 2 would be iterating over arrays, and then number 3 would be iterating over maps. So for k, v in map, string, string, and I don't know, foo, bar, thing as whatever, something like that, right? So that would be the third. So those are I think those are our cases. For infinite for can be done with while true. I know some people here don't care for that, but yeah, that's my answer to that. Actually, this is, just so you know, technically at home I do use a Razer Black Widow Chroma 2. This is a Razer Black Widow Elite because I'm not at my home office and I had to buy a clicking keyboard. So, but they're very similar. Oh yeah, again, like when I say range-based for, that's what I mean. I'm talking about for semicolon semicolon in C or C++. I'm not going to do that, right? I'm not going to do for define some variable, define some condition, define some action. I'm not going to do that. Because again, just the way I tend to use for loops, and maybe I'm missing it or whatever, but the three big cases I can think of are range-based iteration, right? So x goes from 0 to 10, right? And we could do range and x range, right? If you want to do inclusive or exclusive. And again, being able to step and being able to go in the opposite direction, being able to step in the opposite direction, iterating over arrays, right? And so X here is actually going to be some kind of an iterator thing. You gotta figure that out. Hey, Magnum Baguette, And then iterating over maps, right? Iterating over key value pairs. Those are kind of those are the common patterns like I tend to use. Like in this compiler, if I were to go look at for loops, this is probably what I would see. And I don't typically use for loops that much. So, and finally, keep in mind, this is just what I'm putting into the Bootstrap compiler so I can do serious enough development to self-host. With metaprogramming, theoretically, build any kind of construct here you want. So if you wanted a forever, right, like forever, you know, and it would just loop, you could do that. So, so I'm not too worried, right, about if there's cases that I'm missing or whatever. I think adding them should be pretty easy. But for for, this is what we've got in front of us. So definitely range and so range, X range, kind of a deal. Maybe, yeah, so you're basically saying, can you create an array from a range? It wasn't probably something that I was gonna do. Again, like metaprogramming is what answers that question in my mind. So the way that works is yes, eventually you'll be able to do that if you want to. Will the Bootstrap compiler support that? Probably not. Not right away, if ever, right? The self-hosted compiler will, because we'll get deeper and deeper into, you know, metaprogramming for a lot of that. So, but it's not Python, right? So, yeah. Okay, so I am going to, the intrinsic I think is fairly easy because I don't think it really does much. Again, I'm kind of seeing the range X range intrinsic as just placeholders. So, and when I say placeholders, what I mean is they're going to be elements in the model that don't generate code, they just hold parameters. So then for the for element that actually does generate code can say, oh, I was given a range and it goes from low to high or high to low, and okay, this is how I want to generate the for loop, right? So that's how I see the range X range thing working in practice. I need to come up with an iterator type, so I got to think about that. And it's not a generic iterator type, meaning it's not, this isn't even an iterator like that user code can use, at least the way I'm thinking about it right now. For the Bootstrap compiler, maybe once we get into self-hosted stuff, I can come up with something more generic, but because again, this is not an OO language, there's no, you know, top-down type system, right, that percolates through everything. So I don't have an IEnumerable or whatever Java's equivalent is, I forget, streams, iCollection, or collection, I think it's called. So I don't have that, right? There isn't a common type system that would let me just substitute in anything for an iterable. So it may just be that there's an array iterator and a map iterator, and they're just two distinct things. And yeah, and so then, you know, this might just be iterator. I don't know. I got to think about that a little bit. But I probably am going to end up with a type and a type system dedicated for that. Because then the iterator can have things on it like the index and the value and whatever else we want to put on there, right? So the common things that you would want, like one of the things I definitely want to put on my iterator is first, last. So first, true, false, last, true, false. So that you can write a loop where you say, is it the first thing, is it the last thing? Because that's, like when you write loops, I want to add commas. Well, is it not the first and not the last? Then add a comma. Those sorts of little things are things that I want to put in there. Yeah, so then an iterator type of some kind for those cases, whether it's one iterator type that supports both or, I don't know. I haven't thought about that enough yet. I can maybe see how I could do it with both. Yeah, I gotta think about that. So, but that's 4. So that one's gonna take probably most of the week and probably into next week, realistically. And then we're down to a switch, which I think is this is again, I have 2 notions of a switch or matching paradigm, but I think this one's going to be just closer to like a C or C++ switch without the goofy fall through break stuff. It'll be more it'll be more flexible, and it won't be limited to integrals. You'll be able to do a switch on anything. Plus, I'm going to have a specialized construct that you can use either in if statements or in switches for types specifically. So like, let's say you had an any and you wanted to switch on whatever's inside of it, right? You don't have to create a separate enum. You don't have to, you can just say switch with some special intrinsic on this thing, and it'll tell you, these are the different types. And then, because that's common, right? That happens a lot in code. So I guess there, it's like you don't have to manually tag things if you don't want to. The any construct is already tagging it for you. One-line lambda syntax for procedures, I think what I'm going to end up doing there is something like what? Something like what? So let's create another file here real quick. Lambda. Oh, and eventually I need to be, I don't want to have to specify I want to do something sort of kind of like Python, except without all the underscores, where whether it's called modular or init, or I don't know, I still haven't, probably I'll call it init or load, but there will be some file that's the default file for a directory, for a module, and did I lose you guys? No, I'm still here. That was weird. Hope Twitch isn't having problems. It says I'm still connected. Maybe it's just on the client side here. So where was I at? Yeah, so anyway, eventually I gotta fix this to where if you don't specify a file, it will look for one of the defaults. Anyway, that's kind of an aside. But let's say let's say you had a Q sort. Yeah, let's say you have a q sort. And we'll make it generic, which the compiler handles now, sort of. So left and right, and let's have it return back a S8 and stuff, right? No, this is not what I want. I want that. That's what I want. So we're going to have a qsort procedure that takes an array, a pointer to an array of some type, okay? But then we also need a comparator, right? So this is going to take a pointer to a procedure that has a left-hand side T, right-hand side pointer to T, returns S8, right? I don't think this is going to compile right at the moment, but we'll try. And obviously, if you didn't want to repeat this everywhere, you could create a type alias, right? So then you could do pointer to comparator proc. So you don't have to, the prototype you don't have to repeat if you don't want to. But then of course if you do that, yeah, that gets goofy. Because then we have, like how do the generics work? Like I said, there's going to be some stuff I'm going to have to fix here. But let's do it verbose way for now. And then, does this have to be a pointer? I'm going to say the answer there is no, because passing procedures around probably is just always going to be a pointer. So you don't have to make it a pointer. Okay, so like roughly speaking, that's a qsort. And then let's say we have values, and it's a bunch of, actually, let's just do array, U32, 63, 5, 110, 4, 3, 9, 19, whatever. Okay, so we have an array. Then you want to sort. So you would call qsort, pass in your values, and then you would do left-hand side, right-hand side. Something like that, I think, is the syntax I'm going to try. I always liked Smalltalk blocks. I always thought that they were pretty streamlined. So something like this might be the way to go. So for the Lambda stuff, there's going to be a bunch of things I'm going to figure out, I think. Like if I just comment that out, and let's do like I'm not even sure that the compiler is going to handle the, yeah. That's interesting. I thought that was working. That part was working. Of course, I knew I would break it for this. I mean, absolutely. Okay, just didn't like the pointer. Why didn't it like the pointer? Huh. Yeah, so this part I expected, right? Like the parser currently is not, it's not going to handle that right. I wonder if I do an array of pointer to t, will it take that? I think I know what I got wrong there. Yeah, so there's all these little things that need to just be tweaked to support this properly. Yeah, so the type, create type identifier node is just a little off. It's not supporting this flexibly, it's not supporting this. So I need to fix that, but then also, like I was showing earlier, right, you might want to do something like this, but then how do you promulgate the generic parameter, right? So, you know, I guess the obvious solution is I'm going to have to support something like that, right? But yeah, I don't support that at all at the moment. So I'm going to have to think about that. Because I'm not going to want to duplicate procedure prototypes everywhere. I'm going to want to do something like this. Ironically, it didn't bitch about this or that. So I'm not sure if that's a good or a bad thing, but ooh, that's interesting. So we're in a proc expression. Interesting. Yeah. So I'm not to, oh, I know what the issue is. It's confused. Oh, that should be okay. Yeah. Stuff. Lots of stuff. But anyway, this is going to be like the last thing, and you know, as you can tell, right, there's lots of little things that need to be fixed to get it to where it should be. And but then, you know, once we get the setup stuff fixed, then we should be able to get this parsing fairly easily. And I'm not 100% fixated on the syntax quite yet. I mean, it's just one of the first things that came to mind was, oh, hey, you know, small talk blocks were always kind of nice, very simple. And kind of similar to small talk blocks, my thinking here is they're one-liners, right? They're lambdas here are literally lambdas. They're not like, you know, Java and C# and C or C++, you know, you could do full blocks and stuff. I mean, I guess theoretically I could let you just do a block here, but I don't know. So I might put some, you know, constraints on it. I haven't really come to any serious conclusions on that, but yeah, this is kind of going to be my prototypical example, I think, of how I want to try to get all this to work, because this is the kind of thing I think of, right? Being able to inject a procedure, you know, a closure in here that can execute. Yeah, so anyway, those are the plans. So I made some notes about for, I made some notes about lambda. We're actually getting to the end of this list. I'm excited. All right. Where am I from? I am originally from Chicago. I'm actually lived in a suburb of Chicago for a good chunk of my life. I currently live in, well, home is St. George, Utah. I'm currently in Ohio, Kentucky area for work reasons. Yeah, I am still on the lam, Slayer Darth. That's funny. Yeah, I don't know, if I was silicon based, I don't think I'd be in good a shape. Hey, maybe that's why I have so many medical issues. I'm silicon based. All right, so I know typically like I stream until 7-ish, but I'm having to do a lot of off-hour calls this week. So I actually started an hour earlier than I typically do, so I could get a little extra time in versus yesterday. But I do have to run. And yeah, so what's left is, like I say, oops, helps if I can like not be so spastic. Yeah, so for loops, the one-line lambda, the switch thing. I actually think the switch thing is going to be fairly easy. Again, we're not talking about code generation, right? To make that efficient, that's a whole separate thing. Excuse me. These are just tasks so that if you have a switch-like construct in the source code, the parser consumes it, the compiler model models it in a reasonable way so that we can code generate for it. And so yeah, tomorrow morning I will be back online, probably early again, probably like an hour, maybe an hour and a half earlier than typical. And then I don't know, I might have to restructure my schedule again if I'm going to be doing all these super early morning calls. So I'll let you guys know if I do have to change my schedule. But yeah, I'm going to keep chunking away on this. And I think by the end of this week, a lot of, not all of it probably, but most of these will be very close to done at this point. And then we're on to, it's all just, it's going to be stacks, you know, stack frames, scoping, and tidying up stuff, right? So initialization and, you know, module flow and a bunch of other stuff. So, and I've been doing some rereading of code flow analysis. So we're going to be adding in some data structures on the compiler side for code flow analysis. So we're going to do like a dominator model so that we can do proper CFA, and yeah, so we'll be plumbing all that in, and yeah, and then finishing off bytecode generation, then finally getting native code gen going, at least for x86, 64, and yeah, there you go. Okay guys, I gotta run. Thanks for dropping by. I will be back online tomorrow, and I will surprise you with the start time, and hope everybody has a good day. Talk to you later. Bye. Where's my OBS? There it is. Okay. I know what I'm doing, really. See you guys tomorrow.